Let's start off. There, let's get this thing. In a resonance column tube experiment, the first and the second readings are L1 and L2, frequency F, and the speed of sound and the end correction. Kund's tube, Quincke's tube, hope you guys remember this. All these are experiments for finding speed of sound. Let's get them. Hope you guys remember the experiment. So in a resonance column tube, if you look at the experiment, right? So how will this thing be? So the first measurement will be L1 plus E. The second measurement will be L2 plus E. The difference between two wavelengths is lambda by 2. So L2 minus L1 is lambda by 2. From there you get your wavelength. Once you got wavelength, V is equal to F lambda. And L1 plus E is lambda by 2. That's your first harmonic. So from there you get the end correction. And what about Kund's tube? Kund's tube is easy. The distance between two heaps of powder will be like what? One stationary wave. So this is 1, 2, and 3. So this distance must be 3 lambda by 2. So 3 lambda by 2 is 40 centimeters. From there you got lambda. Once you got lambda, we can get the sound V is equal to F lambda, right? And it's a helium gas. So, and we know the speed of sound is equal to root over gamma RT by M. From there you can get the temperature. Clear that? So you find the speed of sound from the Kund's tube and then use the speed of sound formula to find the temperature of the gas. And it is given as helium gas. So you can find gamma from there. 1 plus 2 by 3. And the molecular weight of helium is how much? 4 into 10 power minus 3. Yeah? Be careful if you have to write it in kgs. Don't write 4 directly. What about Quincke's tube? Hope you remember they can experiment in a Quincke's tube. You have two pipes. They're movable. Every time you move the distance by x, the path difference becomes 2x. So he's saying when it is displaced by 10 centimeters, we hear maximum 5 times maximum sound 5 times. So the path difference will be 2x, which is 20 centimeters. From there you will get n lambda, and then frequency is given. You'll get the speed of sound. So Kund's tube and resonance column are based on stationary waves, whereas Quincke's tube is based on interference. So these are the three experiments for finding speed of sound. Resonance column tube, Kund's tube, Quincke's tube. Let's get this done. If decibels increase by 30, how much did intensity change? We have a line source here. at a distance r and 3r, there are 2 points. Find the difference in decibels. If 2 moles of hydrogen and 1 mole of helium are mixed at 300 Kelvin, find the speed of sound. I hope you remember the formula for decibels. In case you forgot, the decibels beta is given by 10 log I by I naught. I is the intensity. I naught is 10 power minus 12 watt per meter square. It's a log scale. So if you increase the decibels by 30, how much did the intensity change? Meaning, did it become double? Did it become 10 times? Did it become 100 times? Like that. Try. We have a minute or two for all three. So how do we do this thing? There, this is the result. You should remember, for every 10 decibels, the intensity becomes 10 times. For every 3 decibels, intensity becomes double, roughly, right? So when the decibels increase by 30, so for every 10 decibels, intensity becomes 10i. For another 10 decibels, again 10 times, so 100i. For another 10 decibels, 1000 times. Clear with that? So every time you double the intensity, if you make the intensity 10 times, the decibels will increase by 10. For a line source, the power is given by, intensity is given by power by surface area, which is 2 pi RL. So power is proportional to 1 by R. So IA by IB will be 3 is to 1. Therefore, the difference in decibels will be 10 log 3. Be careful. For a point source, intensity is P by 4 pi R square. For a line source, it is 2 pi RL. Clear with that? Because here, when this sound travels here, it actually goes in a spherical shell. 2 moles of helium, 1 mole of helium are mixed at 300 Kelvin. Find F average, N1, F1 plus N2, F2 plus N1 plus N2. Find gamma average. Find molecular weight average and substitute the formula. Gamma average RT by molecular average. So when you have a mixture, you have to find average value of gamma and average value of molecular weight and then put it in the speed of sound curve formula. Clear with this? Let's get these two. This is a YX graph for a sound wave. Which point has maximum and minimum pressure? That's a very important formula. dP is equal to minus bulk modulus dou by dou x. Second question, bulk modulus is given, frequency is given, density is given, maximum difference in pressure is 100 pascals. Find the displacement amplitude. Find the ratio of V longitudinal by V transverse wave. That itself is a good question. Huh? In a YX graph, remember this is a transverse wave. In a longitudinal wave. In a longitudinal wave, the particles are going front and back in the direction of X. They're not going up and down. So here y is not the y coordinate. Y is the displacement of the particle in the direction of x. Which points will have maximum pressure and which points will have minimum pressure? A, B, C, D. I think that's a good one. If you know that formula, it goes pretty fast. Narayans, you goofed up. Let me ask you this question. While studying sound waves, what do you study? Pressure or change in pressure? What is the property that you study in sound waves? Pressure or change in pressure? You study change in pressure. You don't study pressure. This was a CET question. They had 4 options like that. While studying sound waves, what do you study? Pressure, change in pressure. They gave something else like. So here dP is not the pressure. dP is the change in pressure at a point. Think. Take a minute more for all 3, then I'll show you. Proper mains level question, huh? So when I say mains level, these are the things which you can solve like, like 4 or 5 steps. You won't need to really do a lot of work. Let me explain you this. See, in that graph, now look at the formula here. dP is minus bulk modulus dou v by dou x. So dP gives you the change in pressure at a point. So wherever the slope is maximum, at point A, the slope is positive. So pressure at A will be P naught, that is atmosphere pressure, minus delta P max. Are you getting? So at point A and C, there's a maximum change in pressure. So be careful with the question. There is a maximum change in pressure. I didn't tell you whether it is a positive change or negative change. Are you getting this? So the change is maximum. If you look at pressure at C, it is a positive change. So it is P naught plus delta P max. Whereas pressure at B and D, there is no change in pressure. So this is P naught only. Is this making sense, everyone? Suppose in the exam they ask you this question, at which point do you have the maximum change in pressure, A and C? Which point has maximum pressure? Basically is asking the compression, point C. Which point has the minimum pressure, point A? I hope you're getting the word. Change in pressure and maximum pressure, they're completely 2 different things. But this question, right, you could have done even with a visually also. There is another way to do this in case you forgot that formula, but definitely remember that formula. Look at this thing. At point A, consider, let's make this picture a little big. So at point A, consider the particle in front of you. So the particle in front of you has a positive displacement, means it is going front. The particle behind you has a negative displacement, means it is going backward. So what is happening? The particles at point A are going away from the point, they're expanding. Means it is a rarefaction, low pressure region. Look at point C. The point behind you has a positive displacement, means you're coming front. The point in front of you has a negative displacement, you're coming back. This region is getting compressed. Is that making sense? So point C is the compression, point A is a rarefaction. It's a lower pressure region. That is one way you can see and figure it out. Clear with this? Now in this, there is another question they can ask you. In a sound wave, What is the phase difference between the displacement and the change in pressure? A sound wave, the phase difference between the displacement and the pressure. Anyone remembers? Right, Vihan. Right, Aditya. Right. Yeah, 90 degrees. Think about this. When you have the equation y is equal to a sine kx minus omega t, when you say dp is equal to minus bulk modulus dou y by dou x, when you differentiate this, you end up with bak. This guy becomes cos. So that will be bak. That would be sine kx minus omega t minus 90 degrees. So the change in pressure is actually out of phase by 90 degrees. The phase difference between this is pi by 2. Be careful. Huh? It's not pi. Clear with this? In a stationary wave, what is the phase difference between 2 points in the alternate loops? Pi. Right? What is the phase difference between 2 points in the same loop? 0. In a diffraction, what is the phase difference between the two light rays coming from the two corners of the slit? 2 pi. Yeah, they'll be in phase. The phase angle between the two light rays from the corner and the center, pi. Because they form a minima, na? And if you take one more here, this will be pi. So pi plus pi will be 2 pi. Getting this? So this is a case where it is a pi by 2. याद आया diffraction में single slit experiment. And what is the next thing? The bulk modulus. And remember the formula? Bulk modulus is delta P max is equal to BAK. This is the formula. Bulk modulus, amplitude and K. Bulk modulus is given, frequency is given, rho is given. So how do I get max difference in pressure is given? I need to find A ka value. So I need to find K ka value. Now, be careful with that. He's saying maximum pressure is 100 pascals. Huh? That means P naught plus delta P max. That's your maximum pressure. Minus P naught minus delta P max. That's your minimum pressure. In दोनों का difference was 100. Delta P max is not 100. The maximum difference in pressure between 2 points is 100 pascals. So delta P max will be 50. If you take delta P max is 100, that will be gone. You will get a different answer. Are you clear with that? The maximum difference in pressure, right? So you have to be very careful. Change in pressure and pressure are completely two different words. तो डेल्टा मैक्स 50 आ गया, बल्क मॉडल्स दे दिया, के का वैल्यू कहां से आएगा? याद है? व्हाट इज वी वेव का फॉर्मूला? रूट ओवर बल्क मॉडल्स बाय रो. That is the formula for the longitudinal wave. V wave is bulk modulus by rho. From there you'll get a V wave. Once you got V wave, from there we can get K ka value. V wave is nothing but omega by K. Omega is nothing but 2 pi F by K. So from here you can get K ka value. There you got everything. So A ka value aa jayega. Sure. What is the ratio of V longitudinal by V transverse wave? What is V longitudinal? Root over Young's modulus by rho for a rod. Huh? So this thing I should say this is for a rod. So V longitudinal will be root over Young's modulus by rho. V transverse will be root over tension by mu. And then we know Young's modulus is equal to tension length by area into delta L. So if you substitute all that, you will get Y ka value is TL by A delta L rho. T will cancel. This is mu. This will be 1 by root strain. Clear with this? That is 1 by root strain. So whenever you get an earthquake, right, you have something called P waves and S waves. So those are transverse and the longitudinal waves. I hope you're getting the formulas here. If you see sound waves at a mains level, it's pretty easy, but there are a lot of formulas you need to remember. Let's get this. We have a hollow pipe, both sides open. If it is cut in half, then what happens to the fundamental frequency? Options will be like this. It becomes half, it becomes double, it will be more than double, it will be less than double, it will be more than half, less than half. Option से ऐसा होगा. If it is cut in half, what happens to the fundamental frequency? Options will be like this. It will double, it will be more than double, it will be less than double, it will become half, it will be more than half, less than half. So options वैसा होगा. More than and less than options भी होगा. Open, अरे. How does it even look like closed? Closed, I would have drawn like this, na God. Look at the picture. I know I don't draw it beautifully, but it is open. Right, Aditya. And in case you're wondering why the hell options are more than and less than, you have to include end correction. Less than half. More than what? More than double or less than half? What exactly? Half, double, दोनों का discussion है. Second one, two tuning forks gives 5 beats with FB. If B is slightly waxed, we get 3 beats. Find FB. F minus 2, F and F plus 2 are sounded together, number of beats per second. Try. Get these three. The 24A is a good one, actually. Most people will forget about the end correction and do the question. But if you include the end correction, it matters. Let's see. This formula, I hope you remember, this is 4. Suppose if this is F minus n and F plus n, you take the two ends. F plus n, F and F minus n, and the number of beats will be 2n. And you also proved, the beats will not have same intensity. You should check out the notes. That would be an advanced question. Find the ratio of intensity of beats. If I ask you the ratio of intensity of bits, it becomes an advanced question. If I just ask you number of bits, it is an easy one. What about this guy? If you cut it in half, first of all here, when you take this, include the end correction. So this was length L. So the idea is this, when you cut a pipe, the end correction does not change. So F is equal to V by 2 times L plus 2E. This was the initial frequency. Now when you cut this into half, the length becomes L by 2, but your end correction still remains the same. So your new frequency will be V by 2 times L by 2 plus 2E. Right? So you can just divide them. F dash by F. V goes off, V by 2 goes off. This will be L by 2 plus 2E by L plus 2E. Right? And I wrote reverse. L plus 2E by 2 times L by 2 plus 2E. So this thing, if you just multiply, this will be L plus 2E by L plus 4E. एक 2B नहीं आएगा actually. The 2 also get cancelled and you'll get an overall 2. This we can clearly see it is slightly less than 2. Right? So F dash must be less than 2F. So it is less than double. Clear with that? So even though when you cut it in half, the length of the overall pipe, including the end correction, will be more than half, isn't it? Because E won't become half. End corrections will still remain E only. Mathematically, you can check it out like that. That's a pretty good one. Please check it out. Ask me if you're confused. Clear with that? So be careful about the cutting thing. If they don't mention anything and you look at the options, more or less than end correction is there. If they don't mention, if they mention, right, neglect end correction, that is okay. Or else be careful. What about this guy? There's still one more question there. So we have two tuning forks. So they're giving initially 5 bits. So FB could have been, the difference is 5. So FB could have been 505 or 495. There are two options. But when you put wax on B, the frequency would decrease. So you waxed it and waxed it. So the frequency would have dropped maybe, and you're getting only 3 beats, right? So maybe this would have been 503 and maybe this would have been 493. I'm just giving some random numbers. And you're saying you're getting only 3 beats. This is only possible if it is 503. So 505 is the answer. Is that making sense? So let's get these three. We have 25 tuning forks. The frequency is increasing. The last one frequency is 400 hertz. Each tuning fork gives you 4 beats. Find the frequency of the 13th tuning fork. The frequencies are increasing till 400. In an organ pipe, the resonance frequencies are 270 and 450. If there are no frequencies between them and it is it open or open closed? Third one, these are the waveforms of a beat. This is produced by F1, F2. This is produced by F3, F4. Compare F1, F3 and compare F1 minus F2 and F3 minus F4. सब क्या था क्लास में? Similar ones. C तो we did in the class. B and A are little different, but you must have seen in some material for sure. You guys got a rocket, kya? This is the thing. Balloon hai abhi. This is how you send these things. Got it. I only can't see. That's the problem. Answers. This is simple backtracking actually. So you want the 13th one, right? So let's say the 13th frequency is somewhere here. This is the 13th guy. Let this frequency be F. So from 13 to 25, there are how many there between them? There are 12 tuning forks between them, right? 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are like 12 tuning forks there. And the difference between them is 4. So F plus 4 into 12 must be 400. F is 352. Clear? What about this thing? So this thing, right? If you see, this increase and decrease in intensity is called 1 beat. Yeah? Whenever you have two waves with a slight difference in frequency, the resultant wave looks like this. You should check out the notes in case you don't remember what is this. So this increase and decrease, increase and decrease. So that increase and decrease is called 1 beat. So here there's only 1 beat here. That means the difference in frequency, when you compare F1 minus F2, magnitude is only 1 beat, whereas F3 minus F4, the difference is 2 beats. And how do you compare F1 and F3? Look at the number of waves. Huh? This thing is so dense. You have a lot of waves in 1 second. You have less number of waves in 1 second. You're getting it? So the number of waves here is pretty high. It's highly dense. So this must be created by very high frequency waves. So F1 must be greater than F3. So if I have to give an example, maybe this is created by 1000 hertz and 999 hertz. Maybe this is created by 200 hertz and maybe 202 hertz. You're getting it? The difference is 2, but the frequency is low frequency wave. Here, these are high frequency waves. So that is how you see. If these waves are closely packed, it means you have more waves per second, isn't it? What about this thing, the resonance column tube thing? So we have two tuning forks here, this thing 270 and 450, and you're saying there is no frequency between them. So what's the difference between them? The difference between them, 270, 450, 180 hertz is the difference. And 180, if you go down, 180 ka difference, it will be 90. Right? So look at the frequencies here. Huh? We got 90 hertz. Then we got 3F, which is 270 hertz. Then we got 5F, which is 450 hertz. Did you notice something? Even harmonics are missing. If F is 90, shouldn't it be 2F, 3F, 4F, 5F? You can clearly see here, 2F is missing, 4F is missing. Even harmonics are missing. Meaning one side is a node and other side is an anti-node. This must be an open closed pipe. And this must be the fundamental frequency because that's the smallest frequency you can get. The smallest frequency for which a stationary wave forms is the fundamental frequency. And the multiples of fundamental frequency are the harmonics. And you are saying you don't have anything between 270 and 450. So the difference between them is 180. So 270 minus 180 must be 90. That must be the other side. And below 90, you can't go. 90 minus 180 will become minus 90. It doesn't make sense. Are you clear with this? So this is an open closed pipe. That is how you get it. If you have all harmonics, it is an open pipe or a closed pipe. But if you have even harmonics missing, it's an open closed pipe. Clear with this? Then, like I said, Doppler is not there, but let's just one question just in case. So we have a vehicle here, frequency F, going with speed U. There is a wall here, which is also going with speed V. So we have the observer inside here. Find the number of beats heard by the car driver. It is there for advance in bits, huh? Number of beats per second heard by the driver. The driver is hearing two sounds, one direct frequency, another the reflection, the echo. Let's get this. If you got this, I think your basic Doppler equation, you're clear. You guys like the speed test so much, yeah? Monday, when I said there is no class, people are not worried about the class. People are like, no speed test, no speed test, no speed test. I uploaded 5 speed tests in the site, Ray. You can go and give it. I had an important appointment there. I couldn't cancel it. So, anyways, मतलब ठीक है that people like this speed test for some reason. Then I think 90 questions are not sufficient anymore. We should push it to maybe 120. अरे Aditya, the difference is 180 ना रे. So 270 minus 180 is 90, right? So you can keep subtracting till you get the small. What is fundamental frequency? The smallest frequency you can get. If 270 was the smallest, then there should be no number below that, right? Then 450 can't be the next frequency then. How do you do this thing? This is a little lengthy. Get this, I'll give you a minute. So waves is one chapter, where it is mostly formula oriented. As long as you know the formulas and the standard models, you will get all the equations. Waves, the heat and thermodynamics, at least at a mains level. Advanced they can really twist it a lot, but mains they won't go beyond. Any answers? F into C by C plus U, C minus U. I don't remember the answer, but let's see. So first thing, who is the source? The sound is coming from here. So this is the source. Who is the observer? The wall is the observer. So the sound will come and the wall will hear F dash. Let's call it F1. So F1, C, right? Observer is on the top. Observer is coming towards the source. So C plus V by source is also coming towards the source. This will be C minus U into F. This is the frequency heard by the wall. Now what will the wall do? Whatever frequency it hears, it will send that only. So this guy is the source who's sending F1. Now the driver is the observer who is hearing F2. The source and the observer will interchange. So F2 will be C, the observer is coming towards you, C plus U. Source is also coming towards you, C minus V into F1. So this is C plus U by C minus V. C plus V into C minus U into F. So the driver will hear F and F2. The driver will never hear F1. The driver will hear the direct frequency. So number of beats per second will be F2 minus F. Subtract them, we'll get the answer. Is that clear, everyone? Got this? Suppose if I ask you this question, what is the wavelength seen by the car driver for the echo? If I ask you this question, what is the apparent wavelength seen by the wall? Find the apparent wavelength seen by the car driver. I told you that. You need not do anything there. It is there in the formula only. Yaad aaya? If you just want apparent wavelength, this is what you have to do. This F1, arrange this C plus V by C minus U by F. So this is C apparent. The numerator is C apparent by lambda apparent. So the denominator is the C minus UF is the lambda apparent. What is the apparent here? This is C plus U by C minus V by F1. Don't simplify it. This is your lambda apparent. So the driver will think the echo has a frequency of C minus V by F1. Are you clear with that? So just put that frequency down and the denominator becomes the lambda apparent and the numerator becomes the C apparent. Because most people know how to find F apparent. The moment I ask you lambda apparent, they start getting confused. So you need not do anything. It is there in the formula only. Keep that one thing in mind. Clear with this? That is more Doppler we will see later on. Heat and thermodynamics. Let's get this thing. We have a rod here, vertical rod, mass M, length L, alpha and S. Heat Q is given. Assume there is no heat loss. Find the change in temperature. We have a square frame, side L, alpha is 0.1. Find the change in area when the temperature increases by 10 degrees. In heat and thermo, there are 5 parts: thermal expansion, calorimetry, KTG, thermodynamics, and heat transfer. Again, like I said, as long as you know standard formulas and methods, you'll get most of them. These are not standard though. These are some weird ones I asked. What are the catch? The first question, they won't ask like this exactly, okay? They'll ask you something like this. There is a rod placed on the floor like this. There's an identical rod placed like this. Identical rods. Both are given same heat Q. Who will have more temperature? They did ask a question like this in JEE Advanced once. The question in advance was this. There was a sphere on the floor and there's a sphere which is hinged at the center. Identical spheres and both are given same heat. Which sphere will have more temperature? That was an advanced question. Long back, but it was still an advanced question. What's the catch? So based on that, I made up this question. I hope you remember or you forgot. So let's see. What is the catch? When the rod temperature increases, the length of the rod will increase. This will become L into 1 plus alpha delta T. That means the center of mass of the rod will shift. So some part of the energy goes into changing the gravitational potential energy. So the heat given to the system will be ms delta T plus mg delta H center of mass. So all the energy will not go into the changing the temperature. Some part will go for changing potential energy. So the advanced question, that was a question. One ball was on the floor and one ball was hinged in the center. So when the ball expanded, this ball expands like this only. The center of mass will not change, but this ball will push the center of mass up. So some part of the heat energy becomes gravitational potential energy. So the temperature will be lesser. Clear with that? So that kind of questions you'll get in the exam. They might not ask you this exact calculation here. And what is H center of mass? This length is L by 2. So this is ms delta T plus mg L by 2 alpha delta T. That's your change in height of center of mass. From here you get delta T. So the rod which is placed horizontally and vertically, the vertical one will have less temperature. What about this thing? If you remember here, if you see here, alpha delta T is 1. This is not small, this is large. If alpha delta T is not small, then the actual formula is this. L final is equal to L naught into E power alpha delta T. This is the actual formula for thermal expansion. If alpha delta T is very, very small, basically we do an expansion here. 1 plus alpha delta T by 1 factorial, alpha delta T whole square by 2 factorial, and so on. And if alpha delta T is small, much, much less than 1, then L final will become approximately L naught into 1 plus alpha delta T. That is how actually it was derived. Are you clear with that? So you have to check if alpha delta T is small or big. Here it is very large. That means this length will be EL, this length will be EL. So the change in area will be E square L square minus L square. E square minus 1 into L square. E is exponential. You can't use a regular formula L into 1 plus alpha delta T. That's a blunder. Clear with this. So this is valid when alpha delta T even is much, much smaller. Generally, it is very, very small. Like I said, this is a little weird one. So be careful, especially when you see that alpha ka value 0.1, 0.2, na, that should light a bulb. But something is wrong here. Clear. Normally, alpha ka value will be in the range of 10 power minus 5. Right? So let's get these two. We got a rod here. There's a 2 points A and B. The temperature is increasing at a rate of t degrees per second. Find the velocity of A and B. The floor is smooth. Second thing, we got a rod there where alpha is equal to alpha naught x. Alpha is changing with position. Find the change in length when temperature goes from 10 to 20 degrees. So be careful about that. You can mix up center of mass there. So first time when you see the question, you'll feel like, what the hell, why will it make a difference? Yeah. But when you realize the expansion happens and the center of mass gets shifted up, things change. So we have a rod on a smooth floor and there. What is the catch? Since there are no external force on the system, center of mass will not move. Start from there. So when you increase the temperature of the rod, rod will expand in such a way the center of mass will remain at the center. Second is a good one. Your thermal expansion alpha is not constant, it is changing its position. Let's see. So when you increase the temperature at a rate of T degrees per second, the center of mass will not move. Right? So this distance was L by 4. So if you take the position of XA, this will be L by 4, 1 plus alpha T. Right? So, or you can write like this thing. So the change in position of delta XA will be L by 4 alpha delta T. Divide both sides by time. Delta XA by delta time. L by 4 alpha delta T by T. Capital T is temperature, small t is temperature. This will be velocity of A. So velocity of A will be L by 4 alpha, that will be T degrees per second I cap. Similarly, you can do for B, that will be L by 2 alpha T minus I cap. Both will be going in the opposite directions. So I can ask you find the relative velocity between A and B. How to do this thing? At a distance x, take a small slice dx. Now in this small slice dx, when you increase the temperature, there's a small change in length. This is your dE. So dE is the expansion in dx piece. We have done something similar in Young's modulus also, if you remember. So dE will be, so what is the formula? Delta L is L alpha delta T. Delta L ka place mein dE is there. L ka place mein dx is there. Alpha delta T. And dx and alpha is alpha naught x and delta T is 10 degrees. That is same for all the pieces, so that's constant. Integrate this. This will be alpha naught 10 L square by 2. Play with this. Clear? Now, before going into this, let me ask you one more. We have a rod on a smooth floor. L alpha Young's modulus area of cross section A. Right? So if temperature changes by delta T, find the strain in the rod, find the stress in the rod. Because this happens due to temperature, we call this thing thermal stress. Similar question, we have a rod between two walls, mu, gravity is there, mass m, length L, Young's modulus A alpha, rod just fits between the walls. Find change in temperature if the rod remains at rest. The first is a standard equation. Yeah. First answer is 0. And second is a standard equation. Both are kind of related. Like actually, when you have both the questions together, you actually understand what is happening. Take a minute, I'll explain you both. Let's see the first one. So understand the meaning of this. When you write the formula here, these two are two different things. When you say delta L is L alpha delta T, and when you write Young's modulus is equal to TL by A delta L, both the delta L's are completely different. Right? Or getting it? So basically, when you write this L final is L into 1 plus alpha delta T, this is the new natural length. You're getting it? This is the new natural length at the new temperature. So when you change the temperature, the natural length of the body also changes. Your natural length is not constant. What is this delta L? This delta L is the final length. Let me like this. So this will be L final minus L natural length. I hope you get the difference. Both the delta L's are not equal at all. They're completely two different things. The symbols look the same. So in our question, the rod ka length was this. So this was temperature T. And the length was L. The rod ka length became L into 1 plus alpha delta T. This is the new natural length. And this is also the final length because you didn't do anything. Therefore, here the delta L, which is the strain, delta L by L, that is the strain, is 0. Therefore, thermal stress is 0. The rod will feel as if, there is no stress inside it. No one has pulled it. It is in its natural state. So in this question, the strain is 0, stress is 0. Is that clear, everyone? Now see the second question. Now this will make sense. Now in this question, when you increase the temperature, this rod would have thought L into 1 plus alpha delta T. This is the new natural length when you increase the temperature. But because of the walls, you couldn't expand. Due to walls, length remains L only. So when you take delta L, that will be L final, which is L minus L into 1 plus alpha delta T. So if you ask the rod what is happening to you, the rod will say, boss, I'm compressed. The rod feels it got compressed. So you should not be comparing with that length, initial length. You're always comparing with the new natural length. Rod feels it got compressed. Are you getting this? Think of like this. Let's say your shirt ka size is M. So you're wearing a shirt size M. You're feeling comfortable and nice. Now I start feeding you like a pig. You eat a lot of cake, pizza and everything. You become fat. Now your natural size is L. Now that same shirt, won't it start becoming stiff and tight to you? The thing is your natural length itself has changed. You're getting it. So when you're increasing the temperature, what you're doing is the molecules inside are vibrating and they're moving apart. So naturally the volume is increasing. Making sense? In that scenario, you will not have any tension as such. So here what you're doing, you're not letting it expand. The rod just was, I'm supposed to be L into 1 plus alpha delta t, but you're not letting me expand. So I feel I'll get compressed. Is that making sense? And then you're done. So basically this will be the normal reaction. This will be the normal reaction. That will be the tension. So Y is equal to NL by A delta L. So technically speaking, this L also must be L into 1 plus alpha delta t. Getting it? But since alpha delta t is small, we neglect this. So this is negligible, and we'll say this approximately equal to L. Because alpha delta t is small, it works out. And then once you get from there, we'll get 2 times friction is equal to mg. F is equal to mg by 2 less than equal to mu into n, and substitute, you'll get the answer from there. Clear with this? Let me ask you one more like this. This natural volumes and lengths, it's a different ball game. Let's say we have a hollow shell. Filled with 0 degree water. Okay, and let's say density of water, this thing is 1 gram per cc. And then what happened? The shell, everything suddenly froze to ice. This became ice, and the density of ice is 0.9 gram per cc. Assume the shell didn't expand, okay? A rigid shell, okay? So it doesn't expand. Well, let's say shell didn't expand. Bulk modulus of the ice is B. Assume shell didn't expand. Find the pressure on the shell. Think about this. You know, anomalous expansion. When water becomes ice, it will try to expand. But you're not letting the ice expand. So that means the shell will feel it is being pushed outside now. This is what actually happens in cold countries. When the temperature outside falls sub-zero, right, the water in the pipes will freeze, it will expand, and if you don't let it expand, they'll crack the pipes. So what they do in cold countries normally, right, night when they're sleeping, they open the tap a little, and they make sure the water is dripping drop by drop. So that water, there's some flow actually. Even if the ice expands, it will just push the water out from the pipe. Your pipes are safe. But anyway, you make sure your plumbing is actually inside the house. If you see India, we put the pipes outside the house. They go outside the walls. In abroad, if you see in cold countries, they have the plumbing, they have a wall, they have a false wall, and the plumbing is between the walls. You need to provide heat to the pipe also. If that freezes, you'll not get water in the washroom. You're going there and taking bath, and ice is coming and hitting on your face. So yeah, let's see how to do this. Also, problem in cars is old cars, they used to use water for cooling carburetor, and that is made of thin copper pipes. So during night time, if you leave it like that, that used to fries and the copper pipes used to break. So what they do, they used to add ethyl alcohol. When you add ethyl alcohol to water, the freezing point goes to minus 30 degrees. Surface chemistry, if the topic is still there. I don't know whether it is removed from the mains portion. How to do this thing? Let's see. Same story again. Now, if you ask the ice, so forget about the shell, okay? Now, if you just take water, let's say the volume is V. When it becomes ice, it becomes density is that thing, it will become 10V by 9. Agreed? Because mass of ice must be equal to mass of water. Mass remains constant, not volume. Mass of water is equal to mass of ice. This is density of water, which is density of water into volume of water, is density of ice into volume of ice. Therefore, volume of ice will be 10V by 9. So when you suddenly froze to ice, the ice will say, this is my natural volume. I am supposed to be 10 V by 9. But because of the shell, I couldn't expand. So my final volume is V. So delta V will be minus V by 9. So the ice ka ball will think someone compressed me by V by 9. Then the bulk modulus ka formula is bulk modulus minus dP by dV by V. Right? So we get dP is equal to minus bulk modulus. dV is how much? Minus V by 9. What is V? 10 V by 9. This V is also the natural volume, na? This is not your initial volume. The ice will think from 10 V by 9, I got compressed by V by 9. Are you getting this? So this would be V by 10. I hope you're getting it. So when the ice suddenly water becomes to ice ball, the shell will experience a pressure of B by 10. And if the breaking stress is less than this, the shell will be safe, or else the shell will crack. All clear with this? So these are natural volume ka questions. Huh? So be careful. What is the natural length? Take a break. Come back by 9:40. We'll continue from here. So let's get these two. So we got a steel scale and we got a 1 meter copper rod. At 20 degrees, the readings are correct. Find the reading of the scale at 40 degrees. So if you see in thermal expansion, right, in solids, there are 5 cases which you have. One is the scales, one is the time period of a pendulum. Another thing was cavities. Another thing was bimetallic strip. एक और था thermal stress. These are the 5 things that you have in the thermal expansion thing for rods. Let's see whether you remember these two. Second thing, we got a pendulum, seconds pendulum, meaning time period is 2 seconds. It gives correct time at 30 degrees. Find the loss or gain of time per day at 10 degrees. Let's get them. Let's see. So what is the thing here? See, this is the formula for this, huh? What is the final length? So the reading of the scale, this is the formula. Will be the actual length of the scale. Think of like this. If the scale length suddenly becomes double, let's say 1 meter scale becomes 2 meters next day, what will the scale think about everything? The scale will think everything has become half. If the scale becomes 3 times, then everything it will become 1/3. So if the scale becomes 1 plus alpha delta t times, then it will think everything has become by that factor. So the reading of the scale will be the length of the object at new temperature by the factor the scale increases. Factor, huh? So what is the length of the object at new temperature? 1 into 1 plus alpha copper delta T by the scale will increase by a factor of 1 plus alpha steel delta T. This would be the correct answer, but they will not give you like this. So bring it up. You can use binomial approximation, then multiply, and you can ignore that delta T square ka term. That will be the final reading. So here alpha copper is greater than alpha steel, so you do get something there. What about this one? So we know the time period is 2 pi root over L by G. We can actually use that error ka thing. dt by T is equal to half dl by L. So this would be dt will be T by 2 dl by L. T is 2 seconds. dl will be L alpha delta T. So here it is decreasing here. So this will be minus alpha delta T, that is minus 10 power minus 4 seconds. That's your change in time period. Now you have to be careful here. The minus sign indicates the time period has decreased. The pendulum oscillates faster. It takes little less time to complete one oscillation. Now understand how the clocks work. The clock does not know what is the exact time. One oscillation it will treat as 2 seconds. Now if that one oscillation takes less time, the clock will still think it is 2 seconds. Isn't it? Meaning, let's say it has actually taken 1.99 seconds to complete one oscillation, but this thing will think it has taken 2 seconds. You're actually counting less, so we actually gain time. Clear? So how much time are you gaining? So you're gaining, so dt alpha is 10 power minus 5 I gave. So alpha t is 2 seconds t by 2 dl. Okay. Hey, temperature is 20 degrees now. That is minus 2 into 10 power minus 4. So that is 2 into 10 power minus 4 seconds per oscillation. Remember, T is the time period, okay, for one oscillation. So every oscillation will gain 2 into 10 power minus 4 seconds. That is 10 power minus 4 seconds per second. So every second, you gain 10 power minus 4 seconds. So for a day, it is 86,400 into 10 power minus 4. That is 8.64 seconds per day. So you actually gain this much time. Clear with this? Meaning your day will be 8.64 seconds less. This will start counting as if the time is running fast. When this thing shows 1 hour, in reality it is something like 59 point something. Clear. So you're actually gaining time. Even though it is not 1 hour, you think it is already 1 hour is over. Clear with this? Bimetallic strip. So we have a copper and iron, both are welded side by side, D and L. L is much greater than D. If temperature decreases, draw the shape. Second thing, we have a hollow shell and a solid sphere of same material and radius r. Who has more volume? Radius r. Yeah, who will have more volume in that same temperature and same heat? and they have same temperature, and when they're given same heat. Let's see. So what are the catch? So when you decrease the temperature, you can clearly see alpha copper is greater than alpha iron. So copper will compress more. So length of the copper will be less than length of iron. So whoever has small length, that should be on the inner side, and whoever has more length must be on the outer side. If temperature is increased, now it would have been the other way. So this would be copper and this would be iron. You can find the radius also. This is theta, and then you can finish from there. What about this thing? You have a hollow and a solid sphere of same material and radius r. Now, if they are at same temperature, volume of the body which will be more. The whole volume, okay, not the cavity, the whole volume. If they're given same heat, then we will have more volume. You took a solid sphere, hollow sphere of radius r, same material. If you maintain them at same temperature, who will have more volume? If you give them same amount of heat, who will have more volume? When the temperature is same, they'll have equal volumes. Now you need to understand something about cavities. Look at this thing. If you have a sheet with two cavities and the points are A, B, C, D, if temperature increases, what happens to AB? So this is the thing about the cavities. A cavity will behave as if it is made of same material as the surrounding. Getting it? So every point with or without the cavity will increase by the same amount, meaning the length AC will increase, length BD will increase, length AB also will increase. So this is another question in CET or main some exam, okay? They said there are two cavities. When you increase the temperature, what happens to A and B ka distance? Most people thought this cavity will expand, this cavity will expand, so A and B will get closer. It doesn't work like that. Think of like this. Imagine, first of all, whenever you have cavities, do like this. Don't make a cavity, okay? Just take a marker, put a dotted line, and put a dotted line. Now increase the temperature. What do you think will happen? The whole thing will expand. So even the dotted lines will expand. Now remove the cavity. Do you still think the distance between them will decrease? You're getting it? So even if you have a cavity, cavities will expand, agreed, but the material between them also will expand. The cavities will get pushed away. Are you clear with this thing? So a cavity will behave as if it is made of the same material as a surrounding. So when you take a hollow sphere and a solid sphere, and when you give them the same temperature, the cavity inside the hollow sphere will also expand by the same amount. So hollow sphere and solid sphere will occupy same volume. Is that clear, everyone? But if I give same heat, something happens. If you give same heat, we know Q is equal to ms delta T. right? You are giving same heat, and delta T is proportional to 1 by mass. And we can clearly see here mass of the solid sphere is greater than hollow sphere because they have same material. Therefore, temperature of the solid sphere will be less than temperature of the hollow sphere. Since the temperature is more, the hollow sphere will expand more. Are you clear with the question? If the temperature is same, they'll expand by same amount. But if I give same heat, the same material, so the solid sphere will have more mass than the hollow sphere. So the temperature will rise less. Is that making sense, everyone? So be careful with this kind of question. So cavities will behave like that. The cavity will behave as if it is a full sphere. It doesn't matter. Let's get these three. We have a container. Gamma is the coefficient of expansion of volume expansion of liquid. Alpha container is alpha. Find the condition if height of the liquid remains constant, independent of temperature. No matter how much I heat, the height of the liquid should not change. V is equal to kT square, K is constant. Find the coefficient of volume expansion. Gamma liquid is 10 power minus 5. Beta of a container aerial expansion is 2 into 10 power minus 5. Find gamma apparent. Nah, most people think 3 alpha. That is a trap. See, this thing also we did a detailed explanation in the notes. You should check it out. So how to do this thing? First, let's take out all the water outside. Okay, let the area be A. Take out the water outside. So this volume will be A into H. So when you increase the temperature, volume will become E into H into 1 plus gamma delta T. Now the container also becomes bigger. The container becomes A into 1 plus 2 alpha delta T. And now you're going to take this water and dump it in this. And you're saying the height must remain same. So A into 1 plus 2 alpha delta T into H must be equal to A into H into 1 plus gamma delta T. You can clearly see gamma is 2 alpha. If gamma is equal to 2 alpha, now think about this. Why will this height affect the water level? Why will the height of the container affect the water level? Water level will get affected because of the area, isn't it? Is that clear? Then what is gamma is equal to 3 alpha? Gamma is equal to 3 alpha. Suppose if you have a scale, on the this thing only, let's say this is a beaker with a scale here. Now it will affect. Now when this thing length changes, the scale also gets messed up. So if we had a scale attached to the thing, the beaker on the readings are there, and that will get affected. This now I should check out. We did this thing in thermodynamics, man. I wrote all pictures there. This was the question: when temperature increases, decreases. Cavity. Where is this? Yeah, ये question था. Exact same question basically. So the height as measured by the scale, the formula changes. It will be gamma is equal to 3 alpha. This thing I said, it can be asked as a matrix matching. Look at this thing. Let's say initially the height was 100. If gamma is less than 2 alpha, the actual height will decrease, scale length also will decrease. When you take gamma is equal to 2 alpha, the height will actually remain same. But if you had a scale on the beaker, it will think the reading became 95 from 100. The apparent expansion will change. Are you getting it? If gamma is 3 alpha, look at this. If gamma is 3 alpha, the actual height will increase, but the scale will think it is still 100. I hope you're getting the difference. So in this question, right, I said the height is with respect to the ground level. But if the question was find the height with respect to the container, meaning the container itself has some scale, then the answer was gamma is equal to 3 alpha. Clear with this? Do you guys remember where else you got gamma is equal to 2 alpha? Taught you in fluid mechanics. A block is immersed in a fluid. Find the condition if the depth does not change. याद आया? That we did in fluids में. We did somewhere here. There. याद है? Gamma is equal to 2 alpha. The depth will not change. Then, what about the B thing? That's a direct result. So gamma is equal to, what is quotient of volume expansion? 1 by V dV by dt. So just differentiate there. 1 by kt square and dV by dt is 2 kt. 2 by t. This came a lot of times, mains of bits kind of thing. What is beta? Beta is nothing but 2 alpha. What is gamma apparent? Gamma apparent is gamma real minus 3 alpha. So just substitute there, you're done. So beta is given there, not alpha. Let's get these two. Hope you remember this graph. Temperature versus time graph is given for a liquid, for a substance. S1, S2, L1, L2. S1 is the specific heat capacity. L1 is the latent heat of fusion, liquid, vaporization, everything. Compare them. Do you guys remember this phase change graph? In calorimetry, there are only two important questions. One is the phase change graph and one is water, ice, and mixing problems. Calorimetry, there are only two things that you have. Compare S1, S2, specific heat of solids, compare latent heat of fusion, compare specific heat of liquids, compare latent heat of vaporization, S of gas. So what are the formulas for this? If I name these points now, O, A, B, C, D, and E, slope OA, right, is proportional to 1 by m into S of the solid. Slope BC is proportional to 1 by m into S of the liquid after solid is a liquid state. Slope DE is proportional to 1 by mass into specific heat of the gas. And if you look at the length AB, the longer the length means it took more time to solid to become liquid. So length AB is proportional to latent rate of fusion, and length CD is proportional to latent heat of vaporization. So the horizontal lengths will tell you about the latent heats, and the slopes will tell you for the solid state. So for OA, the red ka slope is more, so S2 is greater. Green line is bigger. BC mein green line slope is bigger. L1 mein this guy is greater, and this one. No, the green looks more steep. This one. Clear? So it is inverse of the slopes. What about this thing? You guys remember the direct result? The T final will be sigma mi si ti by sigma mi si. If you mix n liquids, this is a direct formula there. M1 S1 T1 by M2 M1 S1. Clear? Let's get these three. We have equal masses of three liquids ABC, 10, 25, 40. They are mixed. Find the temperature. Specific heat capacity is 80 cube. Find the heat required to change the temperature from 100 to 200 degrees. A is constant, T is temperature in Kelvin. What is heat capacity? What is water equivalent? Again, I'm sure you know the terminologies. Let's get them. Let's get them. Let's see. So how to do this thing? So we have equal masses of three liquids, 10 and 25. There is no way out here to solve this. So first let's take A and B. So the temperature is 15 degrees. So we can clearly see A is gaining temperature. So M, specific heat of A, 15 minus 10 is equal to M into specific heat of B, 25 minus 15. So SA is equal to 2SB. Now do it for B and C. M, SB, when you mix them, you're getting 30 degrees. So that is 5. MSC, that is 10. So SB is equal to 2SC. Now when you do for A and C, we don't know the final temperature. That will be MSA. So that would be T minus 10. MSC, that would be 40 minus T. Right, solve this, you'll get 16 degrees. Clear with that? The second one, there's nothing there. You just have to be careful with this. Q is equal to integral ms delta T. When you integrate this will be MA T cube dt. Temperature is going from 373 to 473 Kelvin. Don't put 100 and 200. Just be careful with that. What is heat capacity? M into S. Mass into specific heat capacity is called heat capacity. What is water equivalent? The amount of water which will give you the same temperature change as the body for same heat. If you say a body has 100 grams water equivalent, it means if you take 100 grams of water and the body, if you give them same heat, they'll have same temperature change. Amount of water which gives same temperature change as the body. Let's get these two. 100 grams of ice at minus 50 degrees is mixed with 100 grams of water at 70 degrees. Find the final temperature and the composition. 20 grams of ice is mixed with 30 grams of steam. Find the final temperature and composition. So what is the catch in this kind of questions? When you mix them, we have no idea how much ice and how much water will be left out. So we always start with a common state. We start with an assumption, let everything become 0-degree water. So how do we do that? So, so let everything become 0-degree water here. So we have 100 grams ice at minus 50 degrees. Let's say everything has become 0-degree water. And we have 100 grams water at 70 degrees. So when this guy becomes 0-degree water, it actually releases heat. So Q is equal to MS delta T. So this will release 7,000 calories of heat. So this is released. This guy will not suddenly become water. First, it will become ice. So it will become 100 gram ice at 0 degrees. Then it will become water. So 100 grams of ice at 0 degrees, that will be 100. S of ice is half and temperature is 50. That is 2500. And this is M into L, which is 100 into 80. That is 8000. That means end of the day, we have 200 grams of 0 degree water, and this thing has given 7000 calories of heat, whereas this guy absorbed 2500 and absorbed 8000. We actually have a deficit there. So this thing comes out to be around minus 3500 calories. Now, the question has become like this. You have 200 grams of water at 0 degrees, and someone removed 3500 calories of heat. So think of like that. So change the question completely. So if you remove minus 3500 calories of heat, so for 3500 calories, M into LF, so that would be 3500 by 80, 0 will cancel. 350 by 8, 175 by 4, 4, 1, something, 40, 42 grams, whatever is that. So that will be the things. So 175 by 4 grams of ice, and the rest will be water. Okay with this? So it's pretty straightforward. Huh? See, three things can happen, isn't it? One, if you got zero, means what? Your assumption is right. If you got negative, means what? The heat was actually, you have to give more heat, so the water will become ice. If you got positive, means what? You have excess heat. The water will start boiling and the temperature will rise. Is that making sense? After doing this assumption, you get only three cases. Either you get positive, negative, or zero. If you have zero, your assumption is right. Positive means temperature will increase. Q is equal to M is delta T. If it is negative, the water will freeze back to ice. You guys remember this? How to do now? Now, can you do for the second part? 20 grams of ice and 30 grams of steam. Now you try. I'll give you 2 minutes. So these questions, that's how you do. You have to start with an assumption because you directly can't do that M1, S1, delta T and all that stuff if you don't know the common state. 4500 idea. And यहाँ पे 8000 भी है ना. 20 grams of ice at minus 20 and 30 grams of steam at 100. Any answers? So 20 grams of ice. minus 20 degrees. This will become 20 grams of ice. 0 degrees, then it becomes 0 degree water. <clears throat> 30 grams of steam at 100 degrees. This will become 30 grams water at 100 degrees. Then it becomes 0 degrees water. So this guy will release how much heat? 30 into 540. That looks big. 54 into 3, 150, 16,200. This would be ms delta T, 31 into 100. This is 3,000. This thing will absorb how much heat? This thing requires 20 into half into 20, 200. And this is 20 into 80, 1600. Gone. So we got 50 grams of water, 0 degrees, and we have too much heat. We have 16,200 and 3,000. This is nothing in front of it actually. So this is quite a huge value. 19,200 minus 1,800. That would be 17,400 calories. Phew. Then what to do? Now we have to start boiling this much water. So first let's see how much it will take to go to 100 degrees. I think everything has not become steam also. Steam didn't get converted into water only completely. So this guy would absorb 50 into 1 into 100. That will take only 5,000 calories. Great. So we reached 50 grams, 100 degree water. And you still have 12,400 calories. So this must be equal to m into 540. That would be the mass of the steam. 1240 by 54. Steam is very powerful. Clear with this? So the water cut temperature didn't even go below 100. There's still some steam left off. Clear? So this is what you do. You have to keep going like till the heat becomes zero. You keep increase the temperature. Finish off. Last one for the day. We have a VT graph. Plot PT graph and PV graph. We have a PV graph. How does the temperature vary from A to B, B to C, C to A, and what is the maximum temperature? Steam का temperature 100 degrees होने रहा पूरा. Steam is becoming water. Steam is at 100 degree. I didn't say steam is at 150. You're getting it? If you have steam at 150 and if it is becoming steam at 100, then it is off. If your steam is becoming water, then it's a phase change. Let's finish off. Last thing, the graphs. Hope you guys remember that PV graph in this thing. So when you draw a PT graph, BC and CD will look straight only. BC and CD. AD and BC are isochoric process. They will pass through the origin. Right, and PV is equal to nRT. So P is equal to nR by V into T. So slope is proportional to 1 by V. So more volume, less steep. Who has more volume? BC. So this guy must be BC. I wrote wrong here. Wait. And this guy must be AD. And the red lines must be AB and CD. There, you're done. So this is the graph. This black one. And this point is A. This point is D. This point is C. And this point is B. So the graph is going actually anti-clockwise. Hope you guys remember these graphs. What is PV graph? AB and CD are isothermal processes, so there'll be curves, hyperbolas. This is AB and this is CD. And isochoric process, that's a VT graph. Isochoric will be straight lines like this and like this. This is BC, this is AD. So this point is A, this point is D, this point is B, and this point is C. Clear with this? So be careful. What about this guy? So how do you find the temperature? Now in a PV graph, whenever you want to find the temperature, draw hyperbolas. So hyperbola, hyperbola, hyperbola. So the farther the hyperbola, the more the temperature, right? So in our scenario, let's say this is one hyperbola, that is the smallest one. So that should be the lowest temperature, point A. Then the temperature is like this, and this becomes a tangent basically. So you can clearly see when you go from A to B, you are going on a higher isotherm. So A to B temperature increases. A to B also temperature increases. A to C also temperature increases. C to A temperature decreases. B to C, look at the isotherm. This is B and this is C. So when you go from B to C, this point is the maximum temperature. So you increase and decrease. And luckily the graph is very symmetrical. The maximum temperature happens at the midpoint. The coordinates will be 3V0 by 2 and 3P0 by 2. You should check out the class notes question where I gave you an unsymmetrical graph. You have to find the equation of the line and then you have to do maximum minima. That was a mess. So this was 3P0 by 2, 3B0 by 2 by NR. That's your maximum temperature. Clear with this. So you can play like this. Okay, but that will wrap up for the today. Next class, when we catch up, we'll continue with this. We will do more questions on KTG, thermodynamics, and heat transfer, and so on. Okay, with that, we'll wrap up for the day. I'll see you guys again on Friday. And do remember, there are a lot of tests online on the site also. Like there are 7 plus 15 full syllabus tests online, and there are 5 speed tests online. So you have enough tests. So those who want additional practice, you can give. But again, don't go running behind writing too many tests. If you're giving weekly 3 tests, it is sufficient. Focus more on solving material. Getting it? And if you're already scoring more than 180 plus,